This video is on systems of linear equations. I'm going to be doing two examples of solving systems by substitution. Again, substitution is one of the algebraic methods of solving a system. And as before, you can either have zero solutions, which the lines are parallel. You can have one solution, which is where the lines will cross and it will be a coordinate, an xy coordinate. Or you can have infinitely many solutions, which means that the equations are the exact same. So using substitution, you want to solve one of the equations. As you can see, we have two equations, both with x and y in it. You want to solve one of the equations for one of the letters. It does not matter which letter you solve for, but then you take that equation and you substitute it in to the second equation. So as you can see on this first example, the first equation is already solved for y. That means that this first step is already done. So I'm going to write out the steps that I was just mentioning. So step one is to set one equation, EQN equation, equal to x or y. It does not matter, to either x or y. That one is already done because we already have the first equation equal to y. The second step is to plug or substitute that equation that you just did into the other equation. You don't substitute it back into the one you just did because that won't do anything. Step three is we're going to use PEMDAS to solve for the variable, or SADMEP, because we're going to be doing it backwards. We're going to be using the order of operations. We're going to be using order of operations to solve for the one variable that will remain. This is one of the reasons why we are substituting it. When we substitute it, we will no longer see the variable that we have it equal to. So this one, we're going to substitute it in for the letter y on the other equation. So we will only see the letter x. So step four is once we have solved for this one variable, we can then solve for the other variable because we can plug it back in. So we're going to solve for the second variable. So again, that first step has already been done because our first equation is already set equal to y. So what we will do is we will take this entire expression, and because it's equal to y, we are going to substitute this expression in for this y into the second equation because the y is that 4x minus 9. So I'm going to rewrite this equation using my new expression. So this y is really 4x minus 9. So I'm going to put that in parentheses. 4x minus 9 because I plugged that in for the y, but then the rest of it will stay the same. So I will have minus x is equal to 3. Now I'm going to simplify. There is nothing on the outside of this parentheses to distribute it. That means I'm only distributing a 1. So 1 times 4x is 4x. 1 times negative 9 is negative 9. Then everything else remains the same. So minus x equals 3. So I'm going to combine my like terms on the left. So I have 4x and minus x. That will give me a 3x. And then I still have minus 9 equals 3. I'm going to solve for the x variable. So I'm going to add 9 to both sides to get rid of it all over here. So I'm going to have 3x is equal to 12 because 3 plus 9 is 12. Then I'm going to solve for x by dividing by the 3 on both sides, so x will equal to 4. We have just now solved for the variable that we had remaining. The last step is to solve for the second variable. Because we have what the x value equals to, I can plug it into either one of the original equations. I always go back to my original, plug it in, and solve for y. So the first equation is already set up to be y equals So once I simplify this with the x in it, I'll automatically have y. That's what I'm going to use. I could use a second one. It does not matter which one you use as long as it's one of the originals. So I'm going to plug in y equals, I have that 4, I have an x which I now know is 4, so I'm going to put parentheses 4, because that's the x value, then minus 9. 4 times 4 is 16, minus 9 is 7. So my y value is 7. Now that I have my x and the y, I can write my final solution. And a solution to a system is a coordinate. So the x value of our coordinate is 4, comma, the y value of our coordinate is 7. This is where the two lines will cross at 4, 7. This is our solution. And you can always check to make sure this works by plugging these x and y back into the original. So we already know that 7 will equal to 4 times 4 minus 9. So that first equation we already know will work. The second equation we want to make sure. The y is 7 minus the x is 4. So it's 7 minus 4 equals 3. So it works. So that means that this is the correct solution. On this, you try the second example of substitution. We have to make sure we follow all the steps. So the first step is to set one of the equations equal to either x or y, and neither one of these is automatically equal to x or y. You could look at either equation to see which one is the easiest to do. The easiest way to determine which one to use is look at what you would have to divide by. If you can divide everything in that equation by the number on the variable, then you can do this one quite easily. So I could solve this first equation for x because I can divide each part of this by 8. I could solve the first equation for y because, again, I can divide everything by 8. The second equation, I would not want to solve for x because I cannot divide everything by 3. The second equation, I can solve for y easily because I do not have to divide by anything. That's actually the one you would want to solve for. If you see one of the variables is a 1 in front of it, then that's one you solve for. So I'm going to solve for this equation for the y. All I will have to do is subtract the 3x from the other side. So I will have y equals, if I subtract the 3x, it'll be negative 3x. Then I'm going to keep that positive 23. Now I have solved this the second equation for the y, so therefore I can substitute or plug in to the other equation. I'm going to take this entire expression and plug it in for the y on the other equation. So I'm going to plug this in for the y. Everything else will remain the same. So I'm going to go back through here. I have an 8x. I'm not substituting anything in for that. 8x minus, I have an 8. Then I have my y. I will be substituting for the y, so I have to put parentheses. Now I'm going to plug that entire expression of negative 3x plus 23 in for that y. Then I'm going to close my parentheses. Then I'm going to keep it equal to negative 24. Now, as you can see, we only have one variable in here. It's that x, so I can solve for x. So let me simplify the left-hand side. We will have the 8x, but then this negative 8 must be distributed to everything inside the parentheses. Negative 8 times negative 3x is a positive 24x, and negative 8 times a positive 23 is a negative 184. And this will be equal to negative 24. I'm going to combine my like terms and also go ahead and add the 184 to the other side to get it away from the x's. So 8x plus 24x is 32x. So I have just my x's on the left. I'm going to add that 184 now, and I'll get 184 and a negative 24 will give us a positive 160. Then I'm going to solve for x by dividing by 32. So 160 divided by 32 is going to be 5. So x is equal to 5. Now that we know what the x value is, we can again plug it back into one of the original equations to solve for x. To solve for y. I do not want to plug it into the one that I created or the one that I simplified, because that one could be wrong and then our entire answer would be wrong. So you always want to plug it into the original because that you know is correct. So since the first one has multiple things on the y, but the second one doesn't, I'm going to plug it into the second one. Again, it does not matter which one you plug it into. So into the second one, I'm going to put 3x, and my x is 5, so I'm going to put parentheses 5 plus y is equal to 23. So this will become 15. 3 times 5 is 15. I'm going to subtract it from the 23, so y will equal to 8. Now that we have the x and the y, we can write our solution as coordinate of 5, 8. So our one solution to this system is 5, 8. This is solving systems of equations by substitution.